Recording? Yeah. Right, Professor Brian Cox, welcome to the IET and thank you for joining us today.
Pleasure.
I would obviously like to talk to you about science communication because obviously the Collier Medal is awarded for improving understanding of science and technology, which you've done an awful lot to do. What is it about your approach that makes you so successful, do you think?
I think that I grew up inspired by, I think, one of the greatest science communicators of all time, Carl Sagan. So I remember vividly in 1980 watching Cosmos. I was 12 years old in 1980 when it was on. And the thing that captured my imagination was, I think that it was, now I know, that it was polemical as well as being scientific. It's a celebration of science. And I've been used to, you know, I used to watch Horizon, which I loved. It's about the only place you could get any information actually about things like the Voyager missions to Saturn, Jupiter, and onto Uranus and Neptune and those things. But Sagan had this sort of way of celebrating science, of telling you not only what science has discovered, but why you do it or why we do it. And so I think that was really heavily influenced by particularly Carl Sagan. And then subsequently I found there were other series like that in the 70s as well. The Bronowski's Descent of Man, which I thought was wonderful. And again, it's quite polemical. It's almost political in its sort of, I suppose, in this forceful argument for discovery and the forceful argument for the benefits of exploration, curiosity-led exploration of the universe. So I think that's where I get my kind of style from. It's probably the same as if you're a musician. You get your kind of style from the people you grow up with and the people you listen to when you're 10, 11, 12. And that's the same for me. The people I listen to in particular are people like Carl Sagan.
Yeah. Okay. I mean, certainly. I'm a biologist by background. I love biology, and I've obviously been watching your Wonders of Life show, and certainly as far as I can see it, the way you explain it is you take very, very simple bits of biology and then you build it up to make a bigger picture. But the actual building blocks are very, very simple. Do you think that's the way it works best?
Well, it's the way that I think. I mean, I think it's quite a physicist way of thinking, actually. And interestingly, with Wonders of Life, because it was my idea. It was based. I'd read a book years ago by Schrödinger called What Is Life, which we actually used in the first episode. And I'd read it as an undergraduate, or even before I went to university. So this is the idea I came to the BBC with. I said, this would be really nice if we made a physicist look at biology. And now I know that I hadn't done any biology since the 80s. One of the tremendous things I learned actually is how much it's changed. You know, particularly, I suppose, genome sequencing, but the influence of biochemistry as well, the precision that we know things like the tree of life, and you can say things like 62 plus or minus 1.3 million years ago, 3 individuals floated across the Mozambique Channel, and they were the ancestors of the lemurs, the lemuripods. You know, the fact there are error bars on these things to me was tremendous, because biology was just fossils when I stopped doing it last year. Suddenly it's this enormous high precision science. But I said to it was two actual advisors that I work very closely. One, Nick Lane at UCL, who's written a great book called Life Ascending, which a lot of the series is sort of quite heavily based on that, I think, on that book. And also Matt Corbett at Manchester, who's a professor of zoology. And they both said to me, you physicists, you really are reductionist. You know, and they found it quite interesting and to work with a physicist, I think, because that's what I want to do, because that's what physics is, particularly particle physics.
Yeah.
In particle physics, it's searching for simple laws that lead to tremendous complexity, often in a chaotic manner. So it's not that you can predict the behaviour of large-scale systems from these simple laws. Yeah. But I think physicists are trained to dig for the simple laws. Yeah. So I think that's probably why that series is perhaps unusual, because it was meant to be from a physicist's perspective.
Yeah.
And actually interestingly, it got more biological as we went along, because I learned more biology, got more and more excited about biology. And I think there's the last programme in the series, there's a piece about photosynthesis, which wasn't even in the script. But I got so into the Z scheme and the found it so fascinating, that's all I wanted to talk about. So they filmed it anyway, and that ended up in there. The same with the big animals in the programme actually as well. We began not really wanting to film big animals because we didn't want to go into the natural history unit kind of territory, you know, because of the wonderful things like Planet Earth and that, and you can't compete with those because they film them for years. And so, but actually we got more confident in filming big animals, and I got much more confident with working with them and holding them, and you know, so but it's still a physicist look at biology at heart, I think.
Yeah. Okay, to change tack a little bit now, chemical engineering. Before you became aware of the John Collier Medal and being awarded it, did you know what chemical engineering was? Were you aware that it existed?
Well, yeah, because I'm aware of the UK's industrial base, because I spend a lot of time arguing for more investment in universities. Okay. So I was well aware of the fact that there are, you know, a large part. I mean, I don't. Maybe you know what the figures are. I mean, we tend to have these figures that 6.9% of a GVA comes from physics-based industry, but I think the chemistry one's enormous, actually, isn't it?
Yeah.
I know there. It's like 20-odd%. You see huge figures.
About a fifth.
Yeah.
Of GVA.
So I was aware of it from a lobbying for more science funding aspect.
Okay. Right. Leads me on to my next question. Obviously, something like physics, to get a sort of public hook on physics, you've got space. Everybody looks at the stars. Everybody thinks it's amazing. On something like biology, you've got gorgeous rainforests or cute penguins, or there's always something to hook people in. With chemistry and chemical engineering, it's kind of derivative. Like, what's the hook? How do you think you could make something interesting?
I am going to start the lecture actually with Faraday. So Faraday, one of the great science communicators, started the Christmas lectures in 1825. The first one he gave, 1827, was chemistry. And that's because chemistry is probably one of the easiest things to give a public lecture with. I'm going to do that tonight because I've not got a lot of test tubes and things. But so I think it's a gift. I mean, if you look back through the Christmas lectures, Faraday gave 19 Christmas lectures, and I can't remember the proportion, but at least the first 4 or 5, I think, were chemistry, because it's a gift for a lecturer, because you can do things. I think he did things like he burnt phosphorus in air and then burnt it again to show that it won't burn twice because you've taken the oxygen out of the air, which at the time is kind of bordering on cutting-edge research. Yeah. So he did. I think he did over 80 experiments in his five or six Christmas lectures in 1827. Over 80 benchtop experiments. So I think it's easy chemistry. The thing about astronomy is you can't bring it into the lecture theatre, it's all pictures. And the thing about biology is you can, but it's kind of difficult to bring the lion into a lecture theatre. Well, you can bring chemistry into a lecture theatre.
Okay. So if you were to make a documentary, The Wonders of Chemical Engineering, what would you start with, do you think?
Oh, I'd start with I think because the history of chemistry is really the history of physics, which is the history of science. There's no difference at the time. You can tell from Faraday now is thought of, I suppose, mainly as a physicist and an electric motor and induction and Faraday's law. But actually, of course, he was the professor of chemistry at the Royal Institution, the Fullerian professor. So, you know, the story of the discovery of atomic structure, which again borders on physics. Famously, Ernest Rutherford back in Manchester, when he discovered the nucleus, and said all science is either physics or stamp collecting when he did it, and then got the Nobel Prize for chemistry. So there was, you know, even into the 20th century, you see it's a complete mishmash. And I think actually, in a very healthy way now, that the sciences are becoming more interdisciplinary, as you'll know. Yeah. And that's the way the universities are trying to drive their research, and it's appropriate. And it always was. I think you know, how do you draw a line between physics and chemistry? How do you say that the discovery of the nucleus, the atomic structure, what is that? Is that physics? Is it chemistry? Yeah. It isn't. It's the discovery of the structure of the atom. So I think that there was maybe the temporary tribalism of the 20th century is going to actually get swept away again. Yeah. There's an important point actually as well, which is that, as I said, I spend a lot of time thinking and lobbying for increased funding. The way to do that, the way the scientific community and actually the research community, including arts and humanities, the way to do it is to present a unified front and say what we want is a Britain where there's significantly more money spent on research. Now, what that research is essentially, it's a second order question. The first thing is to say we want to do research, we want to understand nature. And then I think that tribal barriers become problematic then, because if you all start arguing for little bits, then you know, the engineers don't like the physicists and the chemists don't like the biologists, and you're not going to ever get anywhere.
No.
So I think unification is good politically, practically, and actually it's the real way that science is done.
Yeah. Okay. How could the institutions better promote that kind of unity? Because obviously, even within, you know, engineering, all the different institutions all the different disciplines are broken down into different institutions. All the different sciences have their own institution. There's lots of overarching institutions. How do you think they can better bring it all together?
Well, I think about this a lot. I mean, obviously, it's a minefield, this question. I mean, I think one way, I mean, if we're talking about the current situation, I'll give you one example. I think the Royal Institution is I'm going to talk a little bit about the Royal Institution tonight because I'm quite heavily involved in the trying to build a future direction of that place. Now, I think places like that are obviously, they never were particularly engineering institutions or chemistry institutions or physics institutions, that they're about the public, the interface between the public and science. Yes. And so I think one of the things we can do is come together around those communication aspects. I mean, obviously the different professional institutions have different things to do. There's the Institute of Physics, which is a thing, physics teachers and physics lecturers, etc., and the same for the engineers and the chemists. But I think that there are institutions, like the Royal Society as well, where everybody comes together. And I would like to see the Royal Institution reborn, re-energised as a place where all science comes together and lobbies and promotes. So that's one of my kind of dreams, I think, okay. for the future. Okay.
How did you end up going from, well, you know, a physics professor at a university to presenting documentaries? How did that all come about?
The way that I think it happens to many people, like Ian Stewart and Alice Roberts and John Collier and Marcus Sortoy. I was on a Horizon. I was interviewed. I was at CERN, typing away in my office, and the BBC came to CERN. They wanted to speak to some British physicists, and I was just there. So I was interviewed about, it was years ago when we were building the LHC, so we've not turned it on. Yeah. And so it was that really, and I think it's one of the great strengths of the BBC at the moment is that they want academics to present science programmes, and they've been very successful at getting them, finding them, and they tend to find them through things like Horizon, where they just interview someone and they quite like them, and then they interview them again and they quite like them, so they give them a little programme. And you know, I think my first one I did with them was on BBC 4, again about CERN, just a little programme, and then did some Horizons, and that's the way. So it's quite a long process actually. I did a lot of little things before I did one to the solar system, which is the first big thing.
Yeah, everybody knows that one. If somebody had made you choose and you could only present science documentaries and you know, communicate to the public, or you could sit at CERN and be a particle physicist, which would you pick? Well,
I'm going to appear that I'm dodging that question, but I'm not dodging the question. I think it's really important. I think that not necessarily. Well, I think academics should, if they want to, communicate what they're doing to the public. You can't make all of them do it. It would be silly. Some people don't want to, but some people do. And I think we need to make sure that career structures are built such that they can do that. The academics that want to talk about their research, or other people's research, or just promote science, can do it in a university setting, because I think it's very valuable for people to see actual academics, so they can see how they think, and actual scientists. So I wouldn't want to choose. I would actively lobby, actually, not to choose. I think universities should promote people, but they always used to be admin, research and teaching, and those were the things that you did. I think it should be admin, research, teaching and outreach, or explanation, or promotion of science, or whatever you want to. And the mix will be different for everybody, but I think as long as those four things are valued, perhaps equally even at universities, then we'll be better.
Okay, one final question. You have been a pop star. I remember you well. That's my era of pop music.
The early 90s.
Yeah, early to mid, yeah. So you've been a pop star, you've been a particle physicist, you've been a television presenter. What's next?
I don't know. I want to make some more television programmes, but perhaps less of them, because I'm still doing research. I still teach at Manchester, and as I said, I'd like to. The one thing I want to do at the moment is I really want to help in ensuring the Royal Institution doesn't disappear. I think that's I'm really involved in that with many other people. But I think that's really important. So that I'm focused on that at the moment.
Okay. Brian Cox, thank you very, very much.
Thanks.
In the camp.